Whoa, what the? Where am I? Oh wait, I remember now. An MIT professor sent me here to recover the server access codes. If I don't get the codes in time, the server will get destroyed. I'll need your help, viewer. Will you help me? The MIT professor did tell me that each color represented a different difficulty. Green means easy, blue means medium, and red means hard. Alright, player. Looks like we only have 30 minutes to complete all of these, including the ones in the next rooms. Okay, so let's start with the easy one first. Looks like the MIT professor gave me it. Let me pull it up. Where's it at? Oh, there it is. Thank you. Okay, here's our first problem. It says the absolute value of p minus 4 is less than or equal to 1. Alright, so the MIT professor did also tell me that for my answer, we are going to get two numbers, and our numbers, we have to add them up, and if the number is negative, then we're going to take the absolute value of that. If that sounds complicated, don't worry, I will explain it later. But anyway, let's just try to solve the problem. Alright, so recall that the absolute value means the distance from 0. So, for example, the absolute value of x is going to be equal to x. The absolute value of negative x will be equal to x. And this is because it's the distance from 0. So let's just say negative 2, for example. So I'm just going to do negative 2, and I'm going to go 1, 2. So yeah, absolute value of negative 2, it's 2, because it's 2 away from 0. And same thing here, 2. So we got 1, 2. So there we go. That's absolute value. So now what we want this to be is we want it to be less than or equal to 1, which means that this has to be no more than 1. So we want to find numbers that equal either 1 or 0, because absolute value cannot be negative. It always has to be positive. So let's go ahead and see. And I also I didn't say this, sorry about that. This can equal negative 1 since, yeah, obviously, this can be the absolute value of negative 1, which is 1. So P here is going to be, let's see, the lowest value here is 3, since 3 minus 4 is negative 1, and that's 1. So 3 is going to be our lower end. And then at the top, it's going to be 5. So that means we have 3 is less than or equal to x is less than or equal to 5. So there we go. And how we graph that is, since this is less than or equal to, we use dots, not circles. So I'm going to put 3, 5, and then I just want to make sure that it's bold. I'm going to draw the line. So there we go. That's our answer. And now we have 3 and 5. So 3 plus 5 here is 8. 8. There we go. We did it. That's the answer. Okay, let me put that in. Okay. Yes. 8. We did it. Okay, let's move on to the medium one now. Alright, here's our next one. I am actually going to give you a different way, because for the harder problems, it is going to get significantly harder. So one thing you can understand is that the absolute value is for negatives. So what I'm actually going to do here is, for this problem, I'm going to put negative 48 over here. And why I'm doing this is because then now what we're going to be able to do is we're going to be able to have a better visualization, because in the last problem we had compound inequalities, and now we have a compound inequality. So now what we're going to be able to do is we're going to divide by 6 on each side, and this is going to equal negative 6 is less than or equal to x minus 1 is less than or equal to 48. No, not 48, I lied. 6. Or actually, no. No, not even. I lied again. Sorry about that. It is going to be equal to negative 8, because 48 divided by 6 is 8. Alright, and then we have x minus 1 is less than or equal to 8. And now we add on each side, so that means negative 7 is going to be less than or equal to, x is less than or equal to 9. There we go. And now we just have to add, so 9 plus negative 7, which is just going to be 9 minus 7, is going to be 2. Oh, we have to graph it too. So we're going to put 7 right here, and we're going to put 9 over here. Graph that bad boy, and yeah, we did. Hooray! All right, let's put 2. All right, we're so close. All right, player, it's your turn. Go ahead and try to solve this one by yourself. Now, remember, you don't want to accidentally miss some stuff because notice this is a negative number. And just remember, when you divide by a negative number, you also flip the sign. All right, and then think about our compound inequality analogy, okay? Go ahead and pause the video right now, and then I'm going to review the answer. Good luck. All right. All right, good. Looks like you got this. Let's see if it's right. So negative 3 plus 7, negative 13. So negative 13 plus 7 is equal to negative 6. The absolute value of that is going to be 6. All right, cool. Let's go ahead and go through this real quick. So I am given that we do have negative numbers. So I am going to do 3r plus 9 because this is technically still inside. And this is going to be less than or equal to 30. And now all we got to do left is just include the other side. So we do negative 30 is less than or equal to that. And, oh, we can remove the absolute value now, since technically, if we are turning this into a compound inequality, we don't need the absolute value signs, because that is literally what it means. So we're going to do 3r plus 9 is less than or equal to 30. Oh, and this can be negative, since we do have to combine both. All right, we're going to divide by 3 on each side. It's going to be negative 10 is less than or equal to r plus 3 is less than or equal to 10. Subtract on each side. Negative 13 is less than or equal to r is less than or equal to 7. Okay, 6. Good. Let's go ahead and move on. Alrighty then. Let's go ahead and put it in, see if it works. Yes! We did it! Woo! Alright, let's, what? There's another vault. Oh, man. Ugh, alright. Let's see what the next code is. Alright, here's the next problem that I'm given. Okay, player, I'm so sorry. It looks like you're gonna have to do the problems by yourself. The MIT professor says that it's not plausible for you to do it if it's just that. So yeah, just go ahead and try to solve this first problem and see what it is. I'll give you some time to think. Did you get that? Alright, yeah, let's go through this real quick. Okay, so first what we want to do here is we want to multiply each side by 8, and this is going to get our stuff isolated. So 8a minus 8 is going to be less than or equal to 24. Negative 24 is going to be less than or equal to 8a minus 8 is less than or equal to 24. Divide each side by 8, and that's going to be negative 3 is less than or equal to a minus 1 is less than or equal to 3. Add each side, and it's get negative 2 is less than or equal to a is less than or equal to 4. And, okay, 2. Good. Okay. That's our first number. Alright. Alright, player. This is the next one it gave me. It's like, yeah. If you want to go ahead and just solve that, that would be great. Okay, negative 3, 0. Okay, let's go through this real quick. Alright, yes. So what we want to do here for this one is we want to divide each side by 10, which is going to give us negative 4x plus 6 is less than 6 or equal to. And that's going to be negative 6 is less than or equal to 4x plus 6 is less than or equal to 6. Subtract each side by 6 because we cannot... Actually, no, I lied. We can divide each side by 2 to get to x plus 3 is less than or equal to 3. Subtract each side, and it's going to give us... negative 6 is less than or equal to 2x is less than or equal to 0. Divide each side. Negative 3 is less than or equal to x is less than or equal to 0. Okay, and I forgot to do this. Sorry about that. Negative 3 is 0. You just do that. Yeah, good. Okay, last problem. And that would be 3 for the, what's called the code. Alright. Remember, don't forget to change the sign. You got this. Okay, 0, 4. Okay, let's see. How do we get that? 2x minus 4 is going to be less than or equal to 4, because we flip the sign, and for each. Now we get negative 4 is less than or equal to 2x minus 4 is less than or equal to 4. Divide each side by 2, it's going to be negative 2 is less than or equal to x minus 2 is less than or equal to 2. At each side, it's going to be negative 4 is less than or equal to x is less than or equal to 0. And to graph that, we just got to do bada bing, bada boom, and line. Easy peasy, lemon squeak. Oh, wait. 0 and 4? Let's see here. Oh, I subtracted. Whoops. Alright, so what we want to do, actually, instead is, yeah, add, not subtract. That's my bad. Wow. So it's going to be adding each side, and that's going to be that. Oopsies. So sorry about that, but hey, that's okay. That's why we're here at FEM, the Foundations of Excellence in Mathematics. Okay, so 2, 3, 4. Let me put that in. Alright, here we go. Fingers crossed. Okay. 2, 3, 2, 4. Oh! It opened! It opened! Oh my gosh! Wait. Huh? What the? This isn't the exit. What? What? That's just outer space. Wait. What's that sound? What is that? Oh. Oh my gosh! What is going on? Why is there so much fire? Oh no. Oh, what is this? Is this like some sort of code? Oh my gosh. Well, I mean, I don't know. Maybe for good luck, we should put in this? Aw, man. Alright, no guessing allowed. Okay, okay, yep, thank you. Okay, we're gonna have to just solve this by ourselves. They gave me this problem, it's a real-world function. Alright, the cooling system is malfunctioning. The server room must stay within 4 degrees Fahrenheit or the entire system will fail. The equation is represented by T minus 72 is less than or equal to 4. Find an inequality that best fits it. Once done graphing, enter the code. Alright, here we go. Let's try it. Go ahead, player, pause the video, and then we'll go through it together. Okay, here we go. So the equation is represented by T minus 72 is less than or equal to 4. Okay, so T minus 72. Okay, we can do compound inequalities. So we can do less than or equal to 4 and negative 4. Okay, add 72 on each side. It's going to be 68. Yep. And then add on each side, it's going to be 76. And then what are the instructions? Oh, the answer is... Oh, combine the numbers. So that would be 6, 8, 7, 6. So let's put that. Okay. 6, 8, 7, 6. Oh, yes, it worked. Okay, alright. We can escape, but we need to put out the fire. Okay, let's get this fire extinguisher. We're gonna put out all the fire, okay? Here we go. Ooh, look at that. Okay, now I have to put out these fires. Okay, that should be everything. I think everything's good now. Okay. Whew. Okay. 72 degrees. Awesome. Okay, now I just have to escape. Alright, sayonara. Woohoo! Yes! Woohoo! Yes, we did it! We saved the servers! MIT must be proud of us. Great job, viewer! For more escape rooms, please consider subscribing to FEM Official. If not, oh well, that's okay. Oh, and P.S. Don't forget about the quiz with the link in the description. Alright, I'll see you guys later. And remember, always love math.